Hi. Last week, week 7, I was supposed to give you some work with the reaction types, which means classifying reactions. However, instead of doing that, I gave you work on balancing equations because I had given the stoichiometry work too early. Sorry about that again. Now, let me tell you about classifying reactions. This is a page from your textbook, and I'll also post a Melissa Maribel video on this same topic. There are several different kinds of chemical reactions. In fact, there are 5 different kinds of chemical reactions that you'll need to know for Chem 65. The first type is the synthesis reaction. Now, a chemical reaction, as you know from your balancing work, has reactants before the arrow and has products after the arrow. The arrow means that the stuff in front of the arrow, the reactants, these guys produce the products, or these guys yield the products, or these guys make the products, or these guys form the products. That's any chemical reaction. A synthesis or combination reaction is one where there's a plus sign in the reactants, but there is no plus sign in the products. Do you know what I mean? I'm talking about more than one thing comes together to form just one kind of compound in the products. Yeah, I know there are 2 of these things, but this is still synthesis. You have 2 things, 2 molecules coming together to form one kind of molecule. This is synthesis. This is also synthesis. 2 compounds coming together to form one compound. That is synthesis. The exact opposite of synthesis is decomposition. You see this? Where's the plus sign? Is the plus sign in the products, or is the plus sign in the reactants? I pointed to the wrong thing. Is the plus sign in the products, or is the plus sign in the reactants? Yeah, that's right. The plus sign is in the products. So this is decomposition, where one kind of thing, one kind of molecule, breaks apart into more than one kind of molecule. Right? It doesn't have to be two kinds of molecules on the product side. It could be 3 or 4 or whatever nature wants there. So that's a decomposition. It's the exact opposite of the synthesis. The other kind is the single displacement reaction. And of course, there's also the double displacement reaction. And I have some pictures to show you about that. Well, I don't have them, but it's in your textbook. So here's an example of a single displacement reaction. Notice we've got zinc plus copper 2 sulfate. Now, in a single displacement reaction, you see this zinc, it is a metal, right? You see this copper in the copper 2 sulfate? This is a metal ion, right? So the zinc ion will replace the copper 2 ion. So it will then be zinc sulfate, and then copper will be by itself. You see? Copper by itself, zinc sulfate. So you could think of this as the book wants you to think of this, which is as a dance party. So there's this fine young gentleman over here, and here's this fine couple over here, and this fine gentleman is like, hey, I want to dance too. And this fine young lady is like, hey, who's that guy with the blue hat? Huh. And then, they switch dance partners for a while. That is the single displacement reaction. Now, in Chem 65, all of our single displacement reactions are going to be involving the positive ion in some compound, and then some metal or something like a metal. So what I mean by like a metal is something that forms a positive ion. So for example, hydrogen. Hydrogen forms a positive ion. So we're going to be working a lot with hydrogen in the single displacement reaction. Also, any metal that is relatively safe and cheap, we will be working with that a lot with Dr. Valdez in the Chem 65 lab. For example, zinc, we will be working with zinc. Magnesium, we will be working with magnesium. Iron, we will be working with iron. I think we will also be working with silver, even though silver is not cheap. How about that? So all of our Chem 65 single displacement reactions have to do with some metal or something like a metal, and some metal ion or some ion like a metal ion. In other words, some positive ion. When you take Chem 101 or Chem 102, you're going to be working with other kinds of single displacement reactions where it's going to be a nonmetal out here, and it's the anion, the negative ion, that's going to get displaced by the nonmetal. But you'll see that in Chem 101 or Chem 102. So it's quite interesting. The double displacement reaction is similar to that, but let me show you the difference. You see, this is a double displacement reaction. It's the same story. It's a dance party, and then there's this red couple and this blue couple. They come to the club, and then this the red couple and the blue couple, they get bored with each other, and so they switch. And so this is now a red and a blue and a red. Okay? Now, your textbook is a little bit sexist here because they have the man always first here. The man is always the positive ion. Now, what's up with that, right? Come on. Isn't it ladies first? This is the 21st century, right? So anyways, this is the positive ion. This is the negative ion. And these ions switch. So this positive ion takes that negative ion. So now it's K with NO3. There it is, KNO3. What happened over here? This is a positive ion. This is the negative ion. So the positive ion switches negative ions with this couple, and so now it's AgCl. There it is, AgCl. What's the difference between the single displacement and the double displacement reaction? The difference is, look at this. This is a pure element. Look at this. This is a pure element. There's a pure element in the reactants for single displacement, but there is no pure element in the reactants for double displacement. There's a different pure element in the products for single displacement, but there is no pure element in the products for double displacement. You see, these are all compounds. So that's the main difference when you're trying to identify reaction types in Chem 65. Of course, there are more important differences, which you will notice once we get deeper into chemical reactions. That won't be for quite a few weeks. Now, it's also important for you to know it's also important for you to know that reactions between metals and nonmetals, of course, we have just seen some reactions between metals and nonmetals, the single displacement reactions, but there are also other reactions between metals and nonmetals, and this section 6.3 in your textbook is trying to help you to understand that the numbers of electrons change for the metals and nonmetals. So in the case of this chemical reaction, the metal here loses 2 electrons and gives them to the nonmetal because the metal wants to be a positive ion and the nonmetal wants to be a negative ion, as you know from your nomenclature work with Dr. Valdez. Now, this is very important, but this is not appropriate for us to learn about right now because there isn't a lab activity about this thing yet. We will learn about this concept, which is called the oxidation and reduction, a little later in the course. You will be combining a metal with a nonmetal in the lab this week. You're probably doing it right now while I'm making this video. You will be combining magnesium, which is a metal, and oxygen, which is a nonmetal. In a reaction very similar to this. This is chlorine, but you'll be making MgO. But you won't be talking with Dr. Valdez about the electrons, I think. You'll be talking about empirical formula, the empirical formula of your product. And that's something that we've already had homework on. So we'll come back to oxidation and reduction if we get a chance at the end of the semester. Now, what's important here is the combustion reactions. Now, a combustion reaction means oxygen is combined with something, and a lot of energy is released. That is a combustion reaction. Now, there are 2 kinds of combustion reactions. There's a combustion reaction which is a synthesis. Do you recognize these reactions as synthesis reactions or combination reactions? Look, where's the plus sign? It's only on the reactants. That means these are all synthesis reactions. So these combustion reactions are also synthesis reactions. But there are other combustion reactions which are not synthesis reactions. Look at this one. When you combust a hydrocarbon, something that contains hydrogen and carbon only, you add oxygen. This is the definition of combustion reaction. You add oxygen and the reaction releases a lot of energy. But the products are carbon dioxide and water, and that's the case for any hydrocarbon. Look at this octane. Octane is a component of your gasoline. Gasoline is a mixture, but octane is one of the molecules in there. And you combine octane with oxygen, and you get carbon dioxide and water. You can combine sugar with oxygen. Sugar is something that contains carbon, hydrogen, and oxygen. You combine that with oxygen, you get carbon dioxide and water if you burn it completely, the way your body does. If you combine, what is this? This is propane gas. Propane gas for barbecuing, right? You combine that with oxygen, you get carbon dioxide and water. That's a combustion reaction, okay? So those are the two kinds of combustion reactions: the synthesis reactions like that, and the hydrocarbon combustion reactions. Hydrocarbon combustion reactions. There it is, hydrocarbons. Excuse me. Now, the last section here is about the double displacement reactions, and this is quite complicated, so I'm going to make a separate video about this. Thank you.